a recording of the teacher who I borrowed the notes from, so I used his recording. But he had a really good explanation. He's super long-winded, worse than me, but he had a really good explanation. So I'll probably post his along with mine if you ever want to go back and look at it. But we're entering this part where it's kind of a weird year because we should have really done this last year, but we didn't. So you're seeing some of it for the first time. So if I go too fast or you've got a question, you guys got to stop me. But we will, you guys are usually pretty good. So we're going to find, how do we find the average value of a function using definite integrals? And I can determine the average value of a function using definite integrals. So the mean value theorem leads into this average value. So I'm going to show you how we can kind of develop it from the mean value theorem. Okay. So I know you all missed my ceiling for the week, right? So if f is a continuous on the closed interval, then there exists a number c in the closed interval such that closed interval a to b such that the integral from a to b of f of x dx equals f of c times a minus b. So really what's happening here is that, remember in the mean value theorem, there's a c value that they can get to exist that is basically kind of the average of the points. Well, that's what they're really saying here. So this is kind of a visual demonstration of what's going on here. So really, when we integrate the left side of this equation, we know that we get the area underneath the curve. Okay, that's what we're really doing when we take an integral. Well, there has to be some point over on and that's what this right side is, that I get a rectangle. So what this is really the formula of a rectangle, the base times the height. The base is the a minus b, right? So this is the a, this is the b. If I subtracted them, I would get that base. The f of c means that there is some point on there, on the graph, such that the area of this rectangle would be the same as the area under the curve. So that's really what the mean value theorem is for integrals. We don't see it a whole lot. We might come up with it just a little bit, but there is a value there. I think there might be one problem in here today in the notes part, but it isn't in the homework. The notes are a little bit more AP-like. The homework is definitely less challenging. So we can actually use this theorem to get the average value formula. So what happens is, in order to find this f of c value, I can actually take this right here and I could divide it over to the other side. So when I divide that over to the other side, I end up with what we call average value. So basically the average, so it'll specifically ask you for average value, and it's average, and value really means anything that has to do with the y, the dependent variable. Okay, it could be the average number of monkeys doing something in a zoo. I don't know, I'm making stuff up. As long as it doesn't say the word average and rate of change, you know you're doing this 1 over b minus a. Okay, and again, we did hit it just a tiny bit. I know when we reviewed last year. Where are the rest of my notes? There it is. Okay, so there's example 1. So this is technically a calculator problem. I'm going to probably end up using Desmos here because I still haven't installed my calculator properly. But I'm going to show the written work first. So we have a function f of x equals 2x e to the negative x squared. And we are supposed to, it's very explicit, we're supposed to find the average value on the interval from 2 to 5. So I'm going to do 1 over my b value, which is 5, minus my a value, which is 2. And then I need to integrate from a to b of 2x e to the negative x squared dx, which this is what we would want to put in our calculator, or in our, I should have put a to b, huh? It's supposed to be from 2 to 5. All right, so this is, again, we could integrate by hand. We could try it. It probably needs a u substitution, but they did tell us it was a calculator problem. So I'm going to go ahead and let my calculator do the work for me. technically when I get a decimal answer like this, I really should put the approximately symbol because it's not really a precise answer. All right, so let's go to Desmos. I haven't even pulled it up yet and see what Desmos does for us. If you do watch the video that I have the other guy's video up, then he will use a TI Inspire, but he has the one with the CAS in it, so which is the computer algebra system. Ours are only CXs. So there's some features he has that we don't, and the solving feature is one of them. So, although it looks like he shows it both ways. So I'm just going to do 1 over, and let's pretend I don't know what 5 minus 2 is, okay, because I can literally just put that in. And then I'm just going to start typing the word integral, and an integral symbol will pop up. And I'm going to go 2 to 5. And then I'm just going to type my function in there, 2x e to the x squared to the x squared dx. And it will give me the value, which is not correct because I was supposed to have a negative x squared. There we go. Now we've got the right value. Remember that we always need 3 decimal places, okay? So, and this one does happen to have the 3. There was somewhere, if we're getting the value off the graph on Desmos, and I haven't explored this yet, we're not getting enough decimal point precision, so we got to kind of be careful. So we're going to put 0.06006. So this is 0.006. All right, now it says find the average value of f of x is equal to f of c. So basically they're wanting us to find the x, or find c such the average value of x, I read it wrong, is of f of x is equal to f of c. So basically what they're doing is they want us to take this right here that we got, and they want us to set it equal to our original equation and solve for the x in the original equation. So 2x, so this is kind of the mean value theorem for integrals at work right here. Now, technically, I really want to use more decimals than what I wrote down, so I'm going to at least go out to the 6th one. And I'm going to kind of trick my graph a little bit and actually graph it and try to find the solution that way. Remember, it's possible we get more than one answer when we do this. Okay, so I'm going to flip again here. All right, so I know I want a y equals, and I'm basically just going to take this line right here. I'm going to copy that number. So I'm highlighting and I'm hitting Control C and Control V. So there's my one line, and I can see that it popped up there, even though it's not, it's really, really close to the 0. I can adjust that in a second. And then I'm going to graph my other equation, f of x equals 2x e to the negative x squared. All right, oh, I didn't put equals. What happened there? There we go. And it's really tough to see the intersections on this. So I'm going to try, let's just try zooming in just a little bit. I'm not sure that that helped. It definitely intersects. Oh, we have to be on the interval. So first of all, the interval, let's go back and look at what our interval was. The interval is from 2 to 5, okay? So that's the only parts where I am allowed to actually have an answer. So in this case, there is technically an intersection point. Look, and it's not quite on, right? At 0, 0, 3, there's an intersection, but that's not on 2 to 5. So I'm going to actually come over here to my settings. I'm going to switch this from 2 to 5, so it's really obvious, hopefully, where my intersection point is. I might want to even, oh, my Y zoomed in pretty good. All right, so it looks like there's a point in here that popped up, so that right there has to be the answer. So I want to use this 2.5974 to give me more decimal points, which is nice, as my answer for this. So it's approximately 2.5. Oh, we got something different on here than they did. 597. 597. So we're okay. All right. The other thing that we want to make, the other thing you could do if you wanted to, is if you wanted to put this on and then just put an X through it and just tell yourself it's not in the interval. If you want to do that, you can, because it isn't in the interval. Okay. Let's take a look at example 2, okay? So we're going to look for the average value again. So, and this time, notice it's not a calculator problem, all right? So this is a do this by hand problem. So what do I need to write out front? I haven't heard much from you guys yet. Go ahead and tell me in the chat, if I'm doing average value, what am I going to have to put out in front of my integral this time? All right, good job. 1 over b minus a. So I'm seeing a lot of 1 over 4 minus 1. Now, you're in BC calculus, okay? I assume you can do 4 minus 1 in your head. So really what I would probably be seeing in here is probably you would just write 3, okay? And I am perfectly okay with that, okay? I hope so, Nate. I really do. Okay, if you can't, it's okay. But it is a non-calculator problem, so I know you had a week off, all right? So now it's time to work again, right? And you only have to work for like 2.5 weeks, and then you get another 2, and then you get 2 weeks off. Okay, so if you can work really, really hard for a couple of weeks, I'll give you 2 weeks off. Okay, I won't even assign any work or anything. All right, so 1 to 4, and then we've got 3x squared minus 2x, and then throw a dx after it. All right, so we're going to go ahead and integrate. We're integrating by hand this time. So we've got 1/3. I know it's been a week, right? And then we're going to integrate this 3x squared. We get 3x cubed over 3 minus 2x squared over 2. How nice is that? From 1 to 4. So I know my 3's cancel and my 2's cancel. So I've got 1/3 hanging out in front. And it's really x cubed minus x squared from 1 to 4. I'm going to go ahead and plug my numbers in. So 1/3, it would be 4 cubed minus 4 squared. And then I'm going to subtract 1/3 times 1 cubed minus 1 squared. The good news is 1 cubed minus 1 squared is 0, so that whole back part cancels. Technically, if I was free response, I would be done. I wouldn't want to do anything else. You probably wouldn't even want to put that x through that line, through that back piece. 4 cubed is 64. And then 4 squared is 16. So we end up with 1/3 times 48. And 3 goes into 48 16 times. All right, so again, we're going to find the values of c guaranteed by the mean value theorem for the integrals for the above function on its given interval. So what do I need to do to actually find the values of c? What's the process? Can you take a minute and explain it to me in the chat, please? So what did we do on the other problem? Okay. I like it, Nate. You're right. So f of x intersects or is equal to 16. So basically, I take my original equation. So this might not be a bad thing to put in the left-hand column in kind of your comments over here. I'm going to take my original equation and I'm going to set it equal to my average value. I'll say it one more time. I'm going to take my original equation and I'm going to set it equal to my average value. Okay, so that's what we're doing next. So 3x squared minus 2x equals 16. Okay, so it's quadratic. Let's see what you remember. Okay, when it's quadratic, what do we have to be equal to in order to solve? Guess I could finish the question. So what do I have to be equal to in order to solve? Zero. Good job. We shouldn't be questioning that. We should know that. All right, so it should be equal to 0. Now, I know it's been a week off, so now we're going to do a magic X. Doesn't that sound like fun? All right, here we go. So let's see, I need to multiply the 3 and the negative 16 together, which is going to give me negative 48. And then negative 2. So I need two numbers that multiply to negative 48 and add to 2. Does anybody have any guesses? Oh, we need 6 and 8. Okay, and it looks like one of them needs to be negative. Nate is suggesting that the 8 be negative. All right, then, this is very rare that I go into this much algebra for factoring in BC, isn't it? Then we need a box. Isn't that exciting? We haven't done a box in forever. So remember, the top left-hand corner is 3x squared, and the bottom right's negative 16. I take whatever's in the magic X and I put it in the other two corners of the box. And then I ask myself, what times what is 3? So 3 times 1, 3 has to go on the side because it divides into the 6, whereas 1's going to go on the top because it doesn't divide into, because it's the only thing that would divide into the 8. Then I ask myself, how many times does 3x divide 6x? And that's twice. I ask myself, how many times does 1x divide negative 8x? And that's negative 8. And then I check it. Negative 8 times 2 is negative 16. So I know my factors are x plus 2 times 3x minus 8 equals 16. So we're going to set both of those equal to 0. Why am I setting them both equal to 0? Impress me. What property are we using right there? I know you all learned it because I taught it to you. So I know you've heard this name of this property before. Many, many, many times. I don't know if there's a delay or we just don't know. Yes, the one where you set it equal to 0. Yeah, it has a name, Nate. I'll give you guys a hint. It starts with the letter Z. And it has to do with multiplication. Any ideas? It's not the word. Madison, good job. You got it. All right, so it is the zero product property. All right, so we're going to, so when you split it and set it equal to 0, it's a zero product property. So x equals negative 2. You get the gold star for the day, Madison, okay? All right, and then we've got 3x equals 8 and x equals 8/3. So you can see that, oh, wait. I can't include one of those, right? Because my interval was from 1 to 4. So and remember, I don't circle my answers either. So from 1 to 4 means I don't get to include the negative 2. So we're going to take that one out. Okay. All right. We still have time for example 3, I think. All of my husband came in here and worked over the break. And so all of my stuff got piled and I have not gotten back to the piles yet. Kind of looks like my desk at work. I'm sure you all missed that. Okay, so we go till 10:50. We still have 20 minutes to do example 3. How exciting. We'll be able to get through it. All right, let's keep going. So this one says, oh my goodness, the copy and paste was not so great, was it? All right, so I apologize if the notes are a little bit wonky. I was copying and pasting and it didn't go very well, apparently. I did change the scenario a little bit. So the guy who I borrowed them from, he lives in Indiana. So I changed the word Indiana to San Jacinto. So it was a little bit more relevant, but I know that we have some dairy farms very, very close by to school. I'm sure you miss all the flies too. So I was over there this morning copying your notes and it smelled wonderful. So the cows on a small dairy farm in San Jacinto are milked in the morning during a 2-hour period. Milk from the cows are pumped into a storage tank, and the volume of milk in the tank at time t is modeled by a strictly increasing twice differentiable function m, where m of t is measured in gallons and t is measured in minutes. At time t equals 0, there are 300 gallons of milk in the storage tank. Values of m of t at selected times t are given in the table. I know that my color is really hard to read there. If this is a t in minutes, I shouldn't have put a slashing, it should be parentheses. And then m of t, and it's measured in gallons. All right, we are supposed to estimate m prime of 70. We have seen this problem a lot. It doesn't have to do with the average value. This is like a whole free response problem, okay? And it's good for our brains to wrap our heads around this. The more times we do this free response problem, the better it will be for us. Indicate units of measure and explain the meaning of your answer in context of this problem. What are we actually finding when they ask us to find m prime of 70 and they give us a table? So what's the calculation that we need to do here? Tell me in the chat. Oh, good job, Nate. Slope at 70. Okay, so that means I need to find in the table where I would surround 70. So we know 70 would be between 50 and 90. Notice it is a calculator problem, so I can use my calculator to help me do the arithmetic piece. So we're doing m prime of 70. I'm going to write out a little bit here to give you like a little skeleton of a problem. You don't necessarily have to do this. You can just put the values in. So really what we're going to use to calculate that is the m at 90, or the y value at 90 minus the y value at 50 over 90 minus 50. So the y value at 90 is 3,360. The y value at 50 is 1,640. 90 minus 50 is 40. All right, when I did hit buttons on the calculator, I got that this is 1720 over 40, which actually comes out nice to 43. What should my label be on this? Tell me in the chat, what do you guys think the label should be? Gallons of milk per minute. Good job. You can just say gallons per minute. Now we need to actually, so it says that that's our estimate. We got the indicate units of measure, but we haven't explained the meaning in the context of this problem. And they might not say, they might just say, explain the meaning of your answer. They might not say the words in context of this problem. You just have to know that you have to put it back in context of the problem. So this is the wording that I would use. The amount of milk in the storage tank okay, because it's a positive number, and this is a rate, right? This was a rate. We would say that it's positive and it's a rate. It has to be as increasing by 43 gallons per minute. And you always have to indicate the time. At time t equals 70 minutes. And remember, it is NUT, right? So a noun, noun, unit, time. So every time I have, I answer one of these in the context of the problem things, I want to make sure I have the noun, which is the scenario, right? There's a restating the scenario, the units, which would be the gallons per minute, and whatever time that occurred at. All right, let's take a look at part B. I'll give you a few seconds. to catch that up. And we'll look at part B. All right, so we are supposed to use the data in the table to evaluate the integral from 0 to 120 of m prime of t. And then in using correct units, we are supposed to interpret the meaning of 0 to 120 of m prime of t dt. So that means I'm going to go ahead and write this out. So I have the integral from 0 to 120 of m prime of t dt. So really, when I go to integrate m prime, I know I get back to m. So I'm m of t from 0 to 120, which means that I have m of 120 minus m of 0. I'll let you catch up. And so far, there really isn't anything super exciting about this being a calculator problem, right? It's more for arithmetic. It isn't for the calculus piece. The calculus piece we really are still doing by hand. All right, so let's take a look at the m of 120 says it's 4,250 and m of 0 is 300. So we're going to subtract those two. So 4,250 minus 300 equals 3,950. And this is, since we integrated, it would be measured in gallons. But I still need to interpret the meaning of in the context of the problem. So because this is a total amount, we went back, we integrated the derivative and we went back to the original. So you got to think of it like a position, okay? So this is talking about the number of gallons of milk that are in addition to what was there to begin with. So this means that 3,950 gallons of milk have been added to the storage tank from time t equals 0 to t equals 120 minutes. Give me just a second, okay? I gotta go check on my son. Finish writing that out. His teacher just lost internet, so I gotta check on him. Hey, Andy, are you okay? Okay, Mrs. Hoffman was on internet. What? So don't freak out. Try to come back. Well, he didn't notice. Oh, you like this better? Okay, good. I'm glad you like it better. I think it'll be a little less intense than what Unit 7 was. Okay. We're gonna go quick though. Okay. It seems familiar a little bit. Okay. What we didn't hit the volume stuff last year, so that's coming. Okay. All right, now we get to use a right Riemann sum with 4 subintervals. My goodness, that did not type well or give us much space to write, did it? I am sorry about that. Use a right Riemann sum with 4 subintervals indicated by the data table to approximate 1 over 120 from 0 to 120 m of t dt. So whenever we see this right here, and they wanted us to interpret the meaning, right? So we're supposed to explain the meaning of the expression in the context of the problem. That's the indicator right there that you have average value, okay? So it's going to be average, whatever the problem is about, okay, when you explain the meaning. So the first thing is we're supposed to use, it said, a right Riemann sum, and this is a fairly typical problem. You'll see this a lot, okay? So I'm going to do my work to the right here because I just don't have space to write to accommodate my handwriting, and I'm sorry about that. Put a sticky note over it. So we have 120, 1 over 120, the integral from 0 to 120 of m of t dt. And we're using a Riemann sum, so we're going to go 1 over 120 is just going to hang out in front. And then I'm supposed to be coming at it from the right. So let me see if I can zoom out just enough to see it here. So from the right means I'm coming from this direction. So I'm going to start with the distance in between. It looks like I need 4 spots. I need bigger space than that though, because big numbers. Okay, so it looks like my first distance in between is 30. And then the height I'm going to use is the 4250. My machine has been doing crazy things today. 4250. Okay, and then the next distance in between looks like 40. And the height is 3360. And the next distance in between is 30. And the height is 1640. And the last distance in between is 20. And the height is 780. All right. Hopefully once we crank, I'll give you a minute, catch up. Technically on the AP test, you wouldn't want to calculate that anymore. Okay, if it does have a calculator, then maybe, but you technically that's the correct answer. You get a lot of the points just for writing that. So when we cranked through the answer here, we should have gotten 2,722.5. What should my label be? Help me out with that part, because I haven't heard from you guys in a while. What should my label be on this? I just integrated. So when I integrate, think about going back to position. It is, it's gallons. Oh, sorry, I got it, it's too small. I was trying to look at my table. All right, it is gallons. All right, so the next piece of this says that we need to explain the meaning in the context of this problem. So because I had that 1 over 120 and I went back to gallons, this is representing the average number of gallons. So we're going to write that out. So the average number of gallons of milk. So this is kind of the noun part in the storage tank from time t equals 0 to t equals 120 minutes is approximately, because we don't know exact, this was an estimate, 2,722.5 gallons. Okay. Then it says, does this approximation, an overestimate or an underestimate of the exact value, explain your reasoning? Okay, so there were some words at the very beginning of the problem. Okay, so I'm going to scroll back up to the very beginning of the problem. Notice it had the words in here, strictly increasing. Okay, so, and we haven't really used that yet, but when you see those words strictly increasing, strictly decreasing, it's a good indicator that there's probably an over or an underestimate coming your way. Okay, so I would probably start drawing myself a picture. So I know strictly increasing looks like that. I know I also just did a right Riemann sum. So I'm going to come like this and sketch my right Riemann sum. So did we get an overestimate or an underestimate? Tell me in the chat, please. Good job. It's an over. So we gotta write that out. So we would say the approximation is an overestimate because we are using a right Riemann sum and the function is strictly increasing. All right, I'll give you a minute there. Are there any questions that we have that we need to deal with at this point? You'll like the homework because this problem isn't even on it there. Well, this would be a really good like test question, wouldn't it? It's because it's not that hard. It's challenging enough to be AP. We've probably seen it a whole bunch of times. I know I did it a ton of times with the BC group last year getting ready. Even if they're easy. The nice thing about what we've been doing more and more is that the nice thing about BC is we can introduce the free response questions so much more that you get really comfortable with them by the time the AP test comes. So it should be like second. It might make you, hopefully the nerves go away. Speaking of making the nerves go away, Saturday there is an AP readiness camp. So be looking for that. I'll probably put some stuff out about it tomorrow because I'll probably have the schedule out tomorrow. So I'm going to go ahead and do the joke of the day because, you know, we need a joke of the day, don't we? It's been a week since we've heard a joke, and now they're holiday themed. So they're, you know, Christmas themed jokes. I'm going to I got to stop recording too because we don't need to record the joke. And you also get to see